Hello guys, hope you're doing well, and as always, if you are new to my channel, I would request you to subscribe to my channel so that you shall be able to watch all my related engineering videos. Alright, thank you. Today we shall be continuing our new series for statics concept builder questions number 3. Okay, we have already done two series of 1 and 2, and we would add some more questions to this tally to basically enhance our understanding of our engineering subject statics. Okay, so today let's see those questions. Over here we have, okay, so the first question that we have is basically using figures define parallel and concurrent system of forces. Okay, so you have to show it to no definition is required, but to trust a sketch and illustration. Okay, so if we want to answer this to define parallel and concurrent system of forces, you can go and see this concept video of our which is I think if you look at it here, this one. Okay, so here we have explained all the basic fundamental systems with its basically I have shown the sketches also for a collinear system, concurrent at a point, parallel system, okay, and concurrent and general force system, and all these systems sketches are being shown over here. How to draw a free body diagram of this section, which is collinear or which is concurrent at a point, and related fundamental independent equations are also being shown to you. So you can just draw these sketches 1, 2, 3, 4, and whatever he asks you, collinear you draw this, concurrent you draw this, parallel he asks you to draw this, and general you should draw this figure, okay, which showing the force system and the moment system in the general case, and the other three it's just the forces are being shown in accordance with the type of the force system we have over here. Okay, so this you can just follow this. All right, define particle equilibrium. If you want to define the particle equilibrium, this is just the basic definition. You can always have a definition over here. You can draw this figure, you can write this equation, and you can write these 3 lines. This is enough to get 2 numbers. Okay, so this is how you define equilibrium of a particle. Okay, so once this has been done, what about this? Define the Saint-Virignan's theorem. Illustrate your answer using a sketch. Okay, the Saint-Virignan's theorem is nothing but it is the explanation of the principle of moments. Okay, so it is, you have to explain the principle of moments, and if you basically go to our this book in which you can understand, if you go to chapter 4, okay, in chapter 4 they have basically explained you the principle of moments over here, and this is the explanation. If you look at it here, he's telling you, if you look, this is in this line he's telling you about what is basically the Saint-Virignan's theorem, and you basically further be telling you about he's a mathematician and basically giving you the concepts also called as principle of moments. Okay, and you have to draw this sketch. You can define, get the definition from here. In this line states the moments of a force about a point is equal to the sum of the moments of the components of the force about the point. Okay, you can draw this figure and you can write this equation with the explanation. And so this is basically what Saint-Virignan's theorem is. Okay, I hope you understand this, and you can just explain it briefly with this equation to get maximum of 2 numbers. Okay, what is this? What is the function of a support in statics? And describe a ball and socket joint. I've just explained. If you go to statics concept builder questions number 2, I have explained what is the function of the supports and describe a ball and socket joint. You can watch my video of statics concept builder question number 2. Okay, you can go to that. Describe a frame structure and also draw a figure representing a frame which is externally loaded. Okay, so you have to explain it what is a frame, and you have to draw any figure of an externally loaded frame structure. So if you look go over here, okay, so this is a frame. Okay, so frames are stationary structures composed of multi-force members, more than 2 forces. They are used to support externally applied loads, and these are all different types of frames being shown to you over here. Okay, so once this is being explained, you can basically uh, take any figure and take it as a frame over here. If you go over here and you go to frames and machines, okay, so these are all, if you look at it, these are all basically kind of, this is a frame structure. Okay, so forces are being explained over here to you. These are all different kinds of frames shown to you basically. So if you look and these this is, you can draw this figure, this is a frame, you can draw this figure arbitrarily. No, definitely you need to learn, it can be any force, any distance. These are all frames, so you can just draw this figure to get the maximum numbers out of it. Okay, so what is this? Define and sketch direction cosines of a force vector in 3D space. Okay, so if you go here and you go here and if you look at it over here, okay, so here it is, direction cosines of a 3D Cartesian vector. You go to statics conceptual reasoning question playlist, and here basically what is, how to define a direction cosine of a 3D Cartesian vector. Direction cosines of a 3D Cartesian vectors are the respective cosine angles which the Cartesian vector makes with the respective x, y and z axis. The angle which it makes with the x-axis is basically alpha, with the y-axis is called the beta, and the z-axis it's gamma, and their cosines with alpha, beta, gamma, when their cosines interacted with the cosines, it basically becomes as direction cosines. Mathematically, direction cosines could be represented as cos square alpha plus cos square beta plus cos square gamma is equals to 1. So this is a very simple explanation. You already know that. I know it's very simple. What about this? Describe under which condition the centroid coincides with the center of mass. Okay, so this is a good problem, a new thing for you guys. So if you go over here, okay, so over here if you go, or if you basically wants to see it interactively, so I have basically added up in my video of the so okay, if not, that doesn't matter. We can basically see the answer for this question for center of mass is this, that this is the main thing. He says to us basically explaining you over here, the centroid C coincides with the center of mass for a single homogeneous material density, which means that if the materials, two different basically geometrical shapes, if they have the same material and they are homogeneous, then the centroid and center of mass will coincide. On the contrary, if we have two different shapes and materials are of different basically densities, they are different materials, the centroid and center of mass will not coincide. Okay, and remember, it will not coincide for two materials with different densities. Okay, so the converse is also true. So I hope this you understand this solution of this problem. Okay, now comes this, describe the characteristics of type 2 friction problems in statics. Okay, type 2 friction problems in statics, it's a very good problem, basically static concept reasoning question. Okay, so if you go here and so here I have explained. Okay, so this is a type 2 friction problem. Okay, this is a type 2 friction problem. So these this is rather a type 1. Okay, so this is rather a type 1 friction problem, and this one, this is a type 2 friction problem. Okay, so this is called as the no impending motion. Over here basically it is basically being termed as the no impending motion. If you go here and basically I have explained you, this is here it is type 2 impending motions at all points. Okay, so basically Here it is very important basically to look at these problems can be identified by the fact that impending motion or slipping of the body at all points can take place at the same time. You can use F equals to Vs at all point of contacts, and the most important thing is to write this equation, that number of unknowns equals to number of equilibrium equations plus the frictional equations. So these are basically the main characteristics of type 2 friction problems, are impending motions at all points. And for the, if you look at the mother friction curve, which explains the frictional forces with respect to the force applied P. Okay, so this type 2 problems are always occurring at this point. If you look at it, it will be always occurring at this point. Okay, so you must remember they will always be occurring at this point. Okay, and then once you go ahead of it, it is these are type 3 friction problems. So I hope this basically understands your concept, and do not forget to write this equation and these basically 1 and 2 and 3 bullets, they are very important. Okay, so I hope this basically explains you the characteristics and type 2 friction problems in statics very clearly. Okay, so this was our third of the series for static concept builder questions. I hope your concept is more clear now regarding these conceptual questions. Thank you very much, and you have a wonderful day.